Hi and welcome. This time around we're going to be working on this vise here, trying to repair it. What happened was that the shaft, the driving shaft on it, got bent so badly that the only way to remove the part out of the vise was to cut it off in my bandsaw, which I've done already. So turns out the threaded section is cast in with or turned in with the rear adjusting portion. Boy, is it tight. So we're going to have to make a new part. What I've done is I purchased some hardened threaded shaft. This is not hardened at all. This was very soft. You could tap with a hammer and it just folded very easily. This is some 4140 pre-hardened shafting, and these are some M2 tool steel shafts here, and we're going to make a new rear piece to go on to the end of this threaded material, and we are also going to create some caps to keep these guys captive. I bought two different sizes, 3/16 and quarter, because I wasn't sure what size I wanted. I think I'm going to settle on the quarter. I think it'll feel better on the hand if you're really trying to cinch down. In the meantime, we got to get the old stuff out here. So the old handle, even this part is bent. We're going to pop that guy out, and you can see where I sawed it off there. And then this top one, to get this piece out, you have to loosen, which I've pre-loosened this off camera. You got to pop the angle section, locking section off, and save the washers. And then the piece that keeps the jaw captive doubles as a pin to keep the shaft captive as well. So you can see there they have turned the end down. Pop this guy out, and now this jaw comes off, and I can pop this piece out. So we're going to need to turn a section in my hardened shaft to match this profile right here, and get the length right, and cut this off, which might be challenging since it's pre-hardened, and then build a piece to go on the back. So first step, let's head over to the lathe and see if we can turn this guy down. Should be some hard turning, makes it kind of interesting. First step's going to be to make a bushing to hold this in the vise. Now in truth, this being a hardened rod, I could almost certainly get away, especially in this Jacobs chuck that has so many fingers pushing out. I could get away with trying to turn this guy just held in there directly, but I like to have bushings anyways, so I don't have a 1/2" 13 bushing, so we're just going to make one real quick. So I'm going to face off both sides of this. We're going to drill and tap for 1/2" 13, take it over the bandsaw, cut it in half, and then part the end off, and we'll just have a clamshell thing to hold, bushing to hold 1/2" 13 threaded rod or bolts or whatever I want that won't damage them. .27/64. Now we're just going to head over to the bandsaw, and we're going to cut this guy in half, all but like the last 1/4 inch, and then we'll come over here and part that 1/4 inch off, which means I shouldn't have bothered facing it. I didn't think far enough ahead. You probably should do a better job of running through all the steps of the process in your head before you get going. Kind of changed my mind, as I often do on these projects, so that's why the order changed. Okie doke, so here I've split the part in half, and I've run a bolt in most of the way to the end so that I can put this back in the jaws here, have something to clamp on, and have it not squeeze closed on the gap here. And I'm going to part off the end, and then I'll reface and chamfer it. So I'm rotating this around so I can see where the parting line is, and we're just going to go right there. And so this will be an interrupted cut. Let me pull you in closer so you can get a better view. Okay. Interrupted face cut. I had to pull the bolt back in a little bit. Okay, so here's my hardened rod, here's my 2 bushings, and I have labeled them so that I can find them again. They're half 13, 1 1/4 inch external diameter. So all you do is just line it up and the threads will pop right in, and there you go. And now I can take this and insert this in here. And now I know that I won't be damaging my threads, especially since what's coming up is hard turning, so I have a little bit of concern about it. We are going to be duplicating this end right here, so it looks like they just went down to the minor diameter. I'll measure it and find out. So first, just to see how hard this material is, I'm just going to try and face off the end, and we're going to do it at 440 RPM. It's supposedly about Rockwell 40 to 45. That's cutting fine. So ultimately, we have to take about 70 thousandths off. So I'm going to try first just to do a 20 thousandths at a very slow feed rate. So it's going to be interrupted a bit. It might have been a better idea just to go right under the threads and take a big bite. It looks like the threads on this threaded rod are deeper than this part, or maybe this part originally down here was just cast. I don't know. Oh, they cut threads into it after. I can see where the threads was being cut in. That's why. As I considered my options, I thought about turning this down even smaller with just a little nub and then building a piece that would be exactly right. But it turns out this vise was designed very sloppy to begin with. This is 0.420 in diameter. The hole is 0.457 in diameter. So I don't think there's any point in trying to make a super precise part out of it, because the rest of the vise is so loose that it's probably a waste of time. I'd be getting nailed by everything else. So what I'm going to do is I'm going to turn this guy down, and we're going to get this just like this part here, leave the little bit of surface, a little bit of the bottoms of the threads, the minor diameter left. It's a very small amount. It doesn't look pretty, but it'll be inside the hole. So we're just going to turn down about, we need to go in about 130 thousandths. So here's the part, and just polished it up a little bit just to make it look nice. We've got to cut this guy to length. Now we're going to make this part here, right here. And what I'm going to do is, we've got some 4140 stock here. We're going to drill and tap it for 1/2 inch, 16 threads, and we're going to 1/2 inch 13 threads, I'm sorry. And we're going to go in about 1/2 inch with the threads. I haven't decided whether Loctite and pin, or braze it in to the shaft itself. Maybe braze would be a better shot. And then we're going to cross drill for a 1/4 inch hole for the cross rod, and we're going to part this guy off. And then we just have to make the 2 caps that go on the cross piece. You can smell the old oil on this. However, if you do grab some Scotch-Brite like this, I first took a file to lightly remove most of the grooves and some Scotch-Brite, you can get a pretty nice looking finish out of it. It's just unfortunate. With the cutter, the way I've been able to get a good finish in the past is to take like 15 or 20 thousandths of revolution feed rate and like 30 to 40 thousandths depth of cut total, and that seems to get a pretty decent finish, but I don't want to lose that much material here. We're going to go in about a ½ inch. .27/64 tap drill size. I can tell already this is going to be fun to tap. Boy, is this tough. So I had to start with a regular tap, and now I had to switch to a bottoming tap just to finish this guy out. And I probably should have done less than 70% threads, because boy is this tight. Alright, so here's the shaft. For the last bit here, we're going to do the end caps that go on the shaft. So we're basically going to be duplicating these end caps, and I'm going to make them press fit. So we're going to drill and ream for 1/1000th under a quarter. So the way I find my zero position here for the edge is I use some shim stock. This is 15/1000th shim stock. I zero my DRO. I move in 15/1000ths for the shim stock, and then 72 thousandths. See, I wrote on the side of this, I'm sorry, 77.5 thousandths, so that I can get this edge lined up with that flat edge. 77.5. We'll go in and we will part this guy off. I've switched to 5C collet so that I can grab these tiny little pieces and get the little nub off of them, and chamfer the back. And 5C collets kind of excel at that, so because most of their holding force is right at the end anyways. So I don't need much material to bite. And we will just trim this off and chamfer. So I got to clean these guys out, but they should be press fit caps. And we'll just finish number 2 here, and we'll be right back. Alrighty, so we've finished our parts here, and all we have left to do, the shaft is a M2 tool steel shaft. That way I can count on it not bending. I mean, it could catastrophically break, but I'm not going to be able to put that much force by hand. So I got to go over to the arbor press and just press these guys in. I made them 1/1000th undersize. So I'm going to go do that, and I'll be right back. That'll be hard to shoot because it's a really awkward location. Alrighty, so here we are for the final assembly. Have all my parts here. Just got to put this guy on there. I decided to braze, to TIG braze the end on. So I threaded this into this part, tightened it a ton by using this shaft, and then used brass and the TIG welder to TIG braze it on. Okay, so we're over, and we can put this guy on now. Okay, that is snugged. Okay, put this guy down. Oh, trick with this guy is actually has indentation, little indented bits for the washers to go in, which is kind of creative. Oh, got it. Okay, thought I left the washer out there. Alrighty, good as old. So our vise is back to operating condition, and it only took about a couple hours to get it in that condition, so no big deal. I think it's got a nice pretty handle now. M2 tool steel, 316 stainless, 304 stainless, or 4140, I'm sorry, 4140 for that part. And the shaft is 4140 hardened. So this shaft, if it gets tightened on or something drops on it, whatever happened last time that caused it to bend, I shouldn't have to worry about that again. And we now have a good working vise. Hope you find it interesting. Thanks for watching. Hope to see you next time.